We need to write these numbers in order of size, starting with the smallest. And just by looking at the list, I can see, because we got negative numbers, one of the negative numbers is definitely going to be the smallest. I can see -7 is the smallest one here. So if I cross that off, I'm going to write it here. I'm then going to look for the next smallest, and that will be -4. And the next smallest, which is -2. And then the next smallest, which I can see is 1. And then last but not least, number 8. Is this our final list? -7, -4, -2, 1, 8. And if you get that all right, you get 1 mark. We need to write the number 8,375 correct to the nearest thousand. Okay, because we're looking to the nearest thousand, we need to find the thousands column. So this one is the units, then we've got the tens, the hundreds, and the thousands. We're then going to look to the number directly after that, which is this 3. We're going to say, is it greater than or equal to 5 or less than 5? It's less than 5, so we round down. So if this was greater than or equal to 5, we would have rounded up to 9,000, but because it's less than that, we're rounding down to 8,000, giving us 1 mark. So we need to write 0.23 as a percentage. Now any number in decimal form, so 0.23 here, is actually a fraction over 1, but we don't normally bother writing this over 1 thing. A percentage is always over 100, so we need to get from here to here. To do that on the denominator, you multiply by 100, so we have to do that on the numerator as well. Multiply by 100, giving us 23. So that equals 23% for 1 mark. We need to find the value of the square root of 17.64. Now, because this is a calculator paper, we just need to put this into the calculator, which gives us 21 over 5. You could also write that as a decimal, which is 4.2 for 1 mark. We need to find the value of 6 to the power of 5. 6 to the power of 5 is the same as saying 6 multiplied by 6 multiplied by 6 multiplied by 6 multiplied by 6. So multiplying 6 together 5 times, because it's to the power of 5 here. And because this is a calculator question, you can either pop this into your calculator, or you can just put this directly into the calculator using the power of button. And if you do that, you should get 7,776, which would get you the 1 mark. There are 14 rows of seats in a cinema, and there are 15 seats in each of those rows. A film was shown in the cinema on Saturday, with each of the tickets costing £6.50. The tickets that were sold cost a total of £1,274. How many tickets were not sold? So I'm going to start off by using both of these lines. And we're going to work out how many seats there are in the cinema. So what's the maximum number of tickets that could be sold? So we've got 14 rows and 15 seats in each of those rows. So we're going to multiply by 15, giving us 210. Which means it's possible to sell 210 tickets if the cinema was sold out. So we're told that each ticket for the film costs £6.50. So if the cinema was to sell out, it would be 210 for the 210 seats, multiplied by 6.5, £6.50. And if we pop that into the calculator, that gives us 1,365. So that's the total cost of the tickets if all the seats were sold. However, we're told that the tickets that were sold totaled a cost of £1,274. So we're going to take the difference between our total number and the number that was actually sold. So 1,365 minus 1,274, giving us £91. So if we think about it, this is the value of the number of tickets that were not sold. So how many tickets does this represent? Well, if we do 91 and divide that by how much each ticket costs, which is £6.50, putting that into the calculator, we get 14. So that's the number of tickets not sold, and also our final answer. So we got our first mark up here for starting off the process, so working out the total number of seats in the cinema. The second mark for the rest of our working here, and the final mark for the correct answer of 14 tickets. Harry has 20 sweets. He gives 7 of the sweets to Nadia. What fraction of the 20 sweets does Harry have now? So in total there are 20 sweets. And after Harry gives his sweets to Nadia, he has 20 minus 7 sweets left, because he's giving away 7 sweets, which equals 13. So therefore Harry has 13 out of 20 of the sweets. So we get 1 mark for 20 minus 7, then the second mark for the correct fraction, 13/20. Here's a number machine. We've got some input, then we multiply by 8 minus 5, and that gives our output. So we need to work out the output when the input is 6. So we're starting with 6, then we go along here and we see we next multiply by 8. So I'm going to do that. And then I'm going to put this in brackets so we know that we're doing this first. Then after that we take all of this in the brackets and we pass it over here, which is minus 5. So we're going to subtract 5 from that, and that gives our output. So we can either pop all of this into the calculator, or we can do it step by step. So we got 6 times 8, which is 48. And then we're subtracting 5 from that, which gives us 43, which is the answer to part A for 1 mark. So for part B, we've got a different number machine. We've got some input, we add 13, we're not sure what this operation is, and then we've got some output. We're told that when the input is 17, the output is 10, and we need to complete the number machine. So using the input they've told us, we're going to have 17 plus 13. Then we've got some mystery operation here, and that's going to equal 10. So if I do 17 plus 13 is 4, and then we've got our mystery operation here, and that equals 10. And if we have a think, how can we get from 4 to 10? We can add 6, because 6 plus 4 is equal to 10. So completing the number machine up here, we're going to have add 6, giving us our second mark. Here is a list of numbers. We've got 6, 4, 8, 9, 4, and 3. And in part A, we need to work out the median. The median is the middle number when we line them all up in order. So firstly, if we get all these numbers in order, so I'm going to look for the smallest one, which is 3. So if I cross that off, we're going to have 3. And the next one, okay, so we've got 4 and 4. So if I cross those off, we've got 4 here and 4 here. The next biggest one is this 6 here. Then we got this 8, and then we got this 9. So what we've got here is all the numbers from up here, but just in ascending order. So the median is the middle number. So to work this out, what we're going to do is we're going to go from each side to work out where the middle is. So if I cross one off this side, we'll cross one off here. One off here, one off here. Okay, so we're now left in quite an interesting situation because we've got 2 numbers. So if I cross this one and this one off, well, there'll be no numbers left. So we're actually going to have to look in between these numbers here. And just by looking at that, you might be able to work out that that's 5. But let's pretend these were a bit more complicated numbers. How you do it is you take both the numbers, so add them up. So we got 4 and 6, and we divide them by 2. Because what we're doing here is we're taking the mean of the numbers, and that gives us 5. So when we take the mean of 2 numbers, that gives us a number bang in the middle. So the median is 5. So we got our first mark for ordering the numbers, and the second mark for the correct answer of 5. Aisha picks at random one of the numbers. And in part B, we need to work out what the probability is that she picks an odd number. Okay, so I've just written out the list of numbers here to make it a bit easier, but it's exactly the same as what we had in part A. So how many do we have in total? We've got 1, 2, 3, 4, 5, 6. So we've got in total 6 numbers. And how many of those are odd? So is this one odd? Nope, nope, nope. Yes, no, yes. So only 2 of the numbers are odd. We've got 9 and 3. So we've got 6 numbers in total with 2 of them being odd. So the probability that she picks an odd number, she's got a 2 in 6 chance. So we're going to write it like a fraction like that. And if we get that correct answer there, we get 2 marks. So now we're told that Clara has 5 cards. There is a number on each card, and 2 of the numbers are hidden. The mode of the 5 numbers is 3, and the mean of the 5 numbers is 5. We need to work out the 2 numbers that are hidden. So I'm going to label these cards so we know what we're talking about. So I'm going to call this card X, and this one over here Y. We're going to look at this line first. The mode of the 5 numbers is 3. So the mode is essentially saying the most common. So this is basically saying the most common number within the 5 of them is 3. Currently, out of the cards that we know the value of, we've got 1, 3, 1, 8, 1, 5. So within those 3, they're all equally as common. But since we know the mode of the 5 numbers is 3, this means that at least one of these has to be 3. So either our X card here or our Y card. I'm going to say our X one is here. So I'm just going to label up here 3. We're now going to take a look at our other line. The mean of the 5 numbers is 5. So we get the mean when we add up all of the numbers and divide by how many there are. So we do 3 plus 3 plus 8 plus 5 plus Y divided by 1, 2, 3, 4, 5. So we're going to do that down here. We're going to have 3 plus 3 plus 8 plus 5. So those are all the cards we've worked out so far. And we've still got the one that we don't know. I'm just going to call that y. And I'm going to divide that by how many there are. There are 5 in total. And we're told that that equals 5. What we've created is an equation. So we can solve this equation to work out the value of y. So I'm going to make this a little bit neater. If we add up these numbers, 3 plus 3 plus 8 plus 5 is 19. So we can say, okay, that's 19 plus y divided by 5 equals 5. Now I don't like this 5 down here very much. So what we can do is if we multiply 5 to both sides. So at the top here, I'm going to multiply by 5. And if I do something on this side, I have to do it on this side as well. So multiply it by 5. This 5 and this 5 cancel, leaving me with 19 plus y equals 5 times 5, which is 25. Lastly, if I subtract 19 from both sides, y is 25 minus 19, which is 6. So our final answer is the two hidden numbers. We've got a 3 and a 6. And we have 1 mark for our working and 1 mark for the correct answer of 3 and 6. Here is the charge at a car park in Spain. The car park is 0.024 euros per minute. So John has parked his car at this car park and he drove in at the time 10:45. When he drove out of the car park, he had to pay €8.40. And we need to work out what time John drove out of the car park. So let's work out how many minutes €8.40 is. So if we do 8.40 divided by 0.024, we get 350. So that means that John must have been in the car park for 350 minutes. So what we need to do is the time 10:45, and we've got to add on 350 minutes. It's a bit easier with times when we're working with like a round time, like 11 o'clock, 12 o'clock. To get to 11 o'clock, we need 15 minutes. So I'm going to do 11 o'clock, and I'm going to get 15 minutes from here, giving us 335 minutes. So what I did there was 350 minus 15. Now I want to work out how many hours is in 335 minutes. So if we do 335 divided by 60, we get 5.583 reoccurring, which isn't a very nice number. However, we do know we've got 5 full hours. So we've got 5 hours and a certain amount of minutes. If we do 5 multiplied by 60, we know that our 5 hours represents 300 minutes. And we've got 35 left over. So it's 5 hours and 35 minutes. So now this is a little easier to work out than before. So we're going to do 11 plus 5 hours brings us to 12, 1, 2, 3, 4. So 4 o'clock or 1600 if we write it in 24-hour format. And then we've still got our 35 minutes left over, bringing us to 4:35. So we got our first mark up here for working out that it's 350 minutes. We got a second mark for going through some sort of process to work out what time that is in the end. This is the way I thought about it in my head, but if there's a different way you thought about it, that's great. And the final mark for the correct time of 4:35. We can use this graph to change between stones and kilograms. And in part A, we're asked to change 3 stones to kilograms. Okay, so if we have a look at our graph here, on the x-axis we've got stones, and the y-axis we've got kilograms. So if I want to change 3 stones to kilograms, first we need to look on our stones axes and find 3, so that's here. And from there I'm going to draw a straight line up until we hit our line on the graph. Once we've done that, I'm going to draw from that point a straight line over to our y-axis. If we have a look at what number this represents, we're going from 10 here, so each square represents 1. So we're going to go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this point here, that is 19. So we worked out that 3 stone is 19 kilograms, giving us 1 mark. Now part B says we need to change 80 kilograms to stone. If we have a look at our graph, we've got a problem, because our graph only goes up to 70 kilograms. This means we can't do the same as before. We can't just read off from here and see where it hits the line, because we haven't got that information. So what we can do instead is if we take our 80 kilograms, and if we divide it by 2, so if I do 80 divided by 2, that's going to give us 40. And now 40 we can read off. So I'm going to go up to 40 here and draw a line, the same as we did before. And now I'm going to draw one down and read off how many stone that is. And if we have a look, our scale, we're going between 6 here and 7 here. So I think each square represents 0.2 because we got 6.2, 6.4, 6.6, 6.8, 7. So here we're in between this line and this line. So 6.2, 6.4, so this is 6.3. So we got that 40 kilograms equals 6.3 stones. But we don't want that, we want 80 kilograms. So if I multiply this side by 2, we're essentially reversing what we did here. We'll get back up to 80 kilograms. But we've got to do the same on the other side. If we multiply by 2, we'll have 6.3 multiplied by 2, giving us 12.6, which is our final answer. So we get 1 mark for converting 40 kilograms, or any other factor of 80 for that matter. Then we get a second mark then for scaling that back up to get the correct answer of 12.6. And it's important to note, because we're reading off a graph like this, it can sometimes be hard to see exactly what the number is. So in the mark scheme, if you're anywhere between 12.4 and 12.8, you'll get the mark. We need to find the number that is exactly halfway between 1 over 10 and 3 over 5. So the way you find the number that's in between two numbers is you take the mean of them. So that means you add them up and divide them by how many there are. And because there's always going to be two numbers when you're working out a number that's directly in between, you're going to divide by 2. So we're going to do 1 over 10 plus 3 over 5. I'm going to put that into brackets because this needs to be done first. And then all of that, we can then divide that by 2. And we put this all into our calculator, including the brackets. Or we can work it out separately like this. So I'm going to work out 1 over 10 plus 3 over 5, which gives us 7 over 10. And then we're going to divide that by 2, which gives us 7 over 20, which equals 0.35. So you write it either as this or this, and you'll get the mark. And as well as the mark for the answer, you get 1 mark for your working, so this bit here. On the grid, we need to draw an enlargement in the shaded shape with a scale factor of 3. If I look firstly at the bottom length here, this is 2. So on our enlarged shape, if we do 2 multiplied by 3, that's 6. So I'm going to start here. I'm going to go 1, 2, 3, 4, 5, 6. So that's our bottom length there. We can undo this one. This is 2 again. So the equivalent on this one's going to be 6. So if I go up, it's going to be 1, 2, 3, 4, 5, 6. Up till there. Okay, now this point's a little bit more difficult. If I look here, we're going 1 along here and 1, 2, 3 up here. So we need to multiply those by 3. So we're going to go 3 along here, and 3 multiplied by 3 is 9. So 9 up. So from this point we said it was 1, 2, 3 along, so here. And then 9 up, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So up to here. Now I can connect up the shape. And if in the exam you had a ruler, you could measure this length and see that it's 3 times larger, and this length to see if it's 3 times larger, to make sure that you got it correct. If you've done that all right, you get 2 marks. A shop sells compost in 20 litre bags and 40 litre bags. One day the shop has 2 special offers. You can get 2 20 litre bags for £3.50 or 3 40 litre bags for £9. Which offer is the best value for money? And we need to show all of our working. So the way we're going to go about this is work out how much 1 litre is worth in each deal, and then we can easily compare them. Now I'm going to call this one deal A and this deal B. So look at deal A first. We've got 2 bags equals £3.50. This deal includes 20 litre bags. Since we got 2 of them, we got 2 times 20 litres for £3.50, which equals 40 litres. Now to get 1 litre, we can divide by 40. So on the left hand side, we get 1 litre. And on the right hand side, if we divide by 40 as well, and I can put 3.50 divided by 40 into the calculator, giving us £0.0875. Great, I'm now going to do the exact same for deal B. So we've got 3 bags equaling £9. And since these bags are 40 litres, we're going to have 3 times 40 litres is £9, which is 120 litres for £9. And we use the same tactic as before. If we divide by 120 on this side, giving us 1 litre, we need to divide by the same on the other side. So 9 divided by 120, if you just put that into the calculator, we get that's 0.075 . So now lastly, we need to do the comparison. 0.075 is less than 0.0875. which means B is better value for money. So writing a little statement to explain that, we've got 0.075 is less than 0.0875. So 3 40 litres bags for £9 is better value for money. We get 2 marks for doing our working up here. Then we get a third and final mark for the correct answer of the 40 litre bags deal, with a little statement to explain why. The length of a plane is 19.2 metres. Lucas buys a scale model of the plane. The scale of the model is 1 to 24, and we need to work out the length of the scale model of the plane, giving our answer in centimetres. So firstly, I can see we're given the length of the plane being 19.2 metres, however we want our final answer in centimetres. So first thing I'm going to do is I'm going to change the metres into centimetres. 1 metre is 100 centimetres, therefore if I times this side by 19.2, we get 19.2 metres. But because I've done it to this side, if I do it to the other side as well, going times 100 by 19.2, we get 1,920 centimetres. So we know that 19.2 metres is 1,920 centimetres. Now if we look at this line, the scale model is 1 to 24. So the length of the scale model is 24 times less than the actual length of the plane. So we're going to take our length of the plane, being 1,920. If we divide that by 24, because we know the model is 24 times smaller, that gives us 80. And because we were working in centimetres here, our answer here is in centimetres. The length of the scale model of the plane is 80 centimetres. And we get our first mark up here for the conversion, second mark for dividing by 24, and the final mark for the correct answer of 80 centimetres. Maria invests £4,500 in a savings account for 3 years. The account pays simple interest at a rate of 1.8% per year. We need to work out the total amount of interest Maria gets at the end of the 3 years. So we're looking at simple interest rather than compound interest. This means the amount of interest we get is based upon the original sum of money. So we see that Maria's starting with £4,500 and we're timesing that by 1.8%. But to carry this out, we want to look at this as a decimal instead of a percentage. So we can convert from a percentage to a decimal by dividing by 100. So if we do that here, we got 1.8 divided by 100, which is 0.018. So I write it out again, we got £4,500 multiplied by 0.018, which equals £81. So this means that each year Maria gets £81 in interest. And since we're looking at 3 years, we just need to multiply 81 by 3. Giving us £243. So we get 1 mark for our working here and 1 mark for the final answer of 243. ABC is a straight line. AB equals BC, which equals BD. And the angle DAB is 64 degrees. And all this information is represented on the diagram up here. And we need to work out the size of the angle marked X, giving a reason for each stage of our working. The first thing that jumps out to me is this triangle here. And we see that this length is the same as this length, which means we've got an isosceles triangle. And within an isosceles triangle, this angle is the same as this angle. So we can draw on there that that's 64 degrees. Now I'm going to label this number 1 because this is the first step we've done. And the reason I knew that angle is because the base angles of isosceles triangle are equal. So now I think we can work out this angle, because all the angles within a triangle add up to 180 degrees. Since we got 2 of them, we can work out the third one. So we're going to have 180 and subtract our first angle, we got 64, and the second angle, which is 64, giving us 52 degrees. I'm going to pop that onto the diagram up here. And we knew that since the sum of the angles in a triangle is 180 degrees. Now next I think we can work out this angle here. Since angles in a straight line add up to 180 degrees, and we've got this angle here, we can work out what this is here. So if I do 180 minus 52, that gives us 128 degrees. And that's since the sum of angles on a straight line is 180 degrees. Now we can do what we did before again, because we see here we've got an isosceles triangle, because this length is the same as this. And like we said in our first step, the base angles in an isosceles triangle are equal. So this is x, but this angle here is also x. And we can also again use the fact that the angles inside a triangle add to 180. So x plus 128 is 180. And that's an equation we can solve for x. So I've got x plus x plus 128 is 180. So that's 2x plus 128 is 180. We subtract 128 from both sides and get that 2x is 52. And therefore x is 52 divided by 2, which is 26 degrees. And that's our final answer. And the reason for that is because the base angles in an isosceles triangle are equal and the sum of angles in a triangle is 180 degrees. And we get 1 mark for each of our steps of working there. Ben is n years old. Chloe is twice as old as Ben, and Dan is 5 years younger than Ben. The total of Ben's age, Chloe's age, and Dan's age is t years. So we need to find a formula for t in terms of n. So this is our initial statement that Ben is n years old. Since Chloe is twice as old as Ben, that means that Chloe is 2n years old, because we're doubling the age. And Dan is 5 years younger than Ben, so that's n minus 5 years. And we're told that the total of all their ages is t. So what we have to do is add all of these up. So n plus 2n plus n minus 5, and set that equal to t. Now we can tidy this up a little bit, because we see we've got an n term, an n term, and an n term. So we've got 1n, 2n, and 1n, giving us 4n. Still got that minus 5 there, and still equaling t. And that right there is our final formula. We get 1 mark up here, and if we got all the components correct, we get final 2 marks. Now part B says that in the table below we need to put a tick in the box next to the identity. So an identity is an equation which is always true no matter what values are substituted. Now that's a bit tricky to get your head around, but if we go through it, if we look at the first one, there's only one value of h that this will be true. So it's 3 multiplied by something plus 2 is 14. There's only one value of h, which this will equal 14. For this one, well, this isn't an identity because it's not an equation. It's not equal something. This isn't an identity, this is a formula. I'm going to skip this one for a second. This one's not an identity for the same reason as the first one. There are certain values of x that I could sub in, for which this will be true, for which this will be less than or equal to 12, but there will be some values for which this is false. This is the one that's an identity. So we've got 5m minus 3m is 2m. Because whatever value of m we have, this is always going to be true. And if we actually think about it, it makes sense, because all of these terms have m in them. So if I divided by m and cancelled out all those terms, we're left with 5 minus 3 equals 2, which is always true. So the m terms don't make a difference. So therefore, this is our identity for 1 mark. Here are the ingredients needed to make 16 biscuits. Anna has 500 grams of butter, 300 grams of sugar, and 625 grams of flour. We need to work out the greatest number of biscuits that Anna can make. Okay, so this is what we need to do to make 16 biscuits. So to make 16 biscuits, we need 175 grams of butter, 75 grams of sugar, and 250 grams of flour. Now, to make things a bit easier, I'm going to see how many ingredients we need to make 1 biscuit. So for 1 biscuit, we need to take these numbers and divide them by 16. So we'll have 175 divided by 16 grams of butter, 75 divided by 16 grams of sugar, and 250 divided by 16 grams of flour. So we can use that to work out how many biscuits Anna can make with these ingredients. So look at the butter first. Anna's got 500 grams. I'm going to divide that by the amount you need for 1 biscuit. So that's 175 divided by 16. And that's a little bit complicated, but luckily we can just put it into our calculator, which gives 45.714. However, we can't make a bit of a biscuit. So that means Anna has enough flour to theoretically make 45 whole biscuits. Now, exactly the same process for the sugar. So Anna's got 300. I'm going to divide that by the amount you need for 1 biscuit, which is 75 over 16, giving us 64. And last but not least, for the flour, we've got 625 grams for Anna. And we're going to divide by the amount for 1 biscuit, which is 250 divided by 16, giving us 40 biscuits. So essentially what we've done there is seen how many times 1 biscuit's worth of stuff can go into the amount that Anna has of that ingredient, giving us the theoretical amount of biscuits Anna could make. Now we're limited by the ingredient that can make the least biscuits. So with this amount of butter, we can make 45 biscuits if we had enough sugar and flour. Or we can make 64 biscuits with this amount of sugar if we had enough butter and flour. But we only have the ingredients that we have, so we need to look to see which is the lowest number here. And that's this one, 40 biscuits. So Anna can make 40 biscuits. So we get 2 marks for this working here, and our third and final mark for realising that it's 40 biscuits that Anna can make. An estimate of the height, h metres of a tall building, can be found using the formula h equals 4f plus 12, where the building is f floors high. A tall building is 110 floors high, and the real height of the building is 442 metres. Seb uses the formula to find an estimate of the height of this building. He then finds the difference between his estimate and the real height. Show that the difference is less than 5% of the real height. So we're first going to imagine that we're Seb, and we're going to use the formula to find out the estimate that Seb would have got. So the building is 110 floors high, and f in the formula is the amount of floors. So we can replace f with 110. So say h is 4 multiplied by 110 plus 12. Popping all of this into the calculator, we get 452. So this right here would have been Seb's estimate. Now we can see that the real height is less than Seb's estimate. So what I'm going to do is take the real height, and I'm going to increase it by 5%. If this number is less than the increased number, the difference is less than 5% of the real height. Or if this is outside of that range, we know that it's not. So to increase by 5%, we multiply by 1.05, giving us 464.1. Now we can compare this number and this number. And since 452 is less than 464.1, the difference is less than 5% of the real height. We get our first mark for substituting into the formula, second mark for finding out that that equals 452, our third mark for our working here, and fourth mark for a final correct concluding statement. The table shows some information about the weights of 50 potatoes, and this frequency polygon was drawn for the information in the table. However, we're getting told here that the frequency polygon is not fully correct, and we need to write down two things that are wrong with the frequency polygon. So first thing I'm going to do, I'm going to ignore the data for the minute. I'm just going to look at the graph. And there's something that jumps out to me straight away that's wrong about the graph. And that's because we haven't labelled the y-axis. We need to remember, whenever we do a graph, we need to label to say what is in the graph so we can tell what's going on. And we see they've correctly labelled the x-axis here. They haven't labelled the y-axis. That's the first thing. And another one that jumps out to me straight away just by looking at this is that we're not supposed to close it off at the end. So these lines are great, having these lines along here. But we're not then supposed to close off the shape. So what I can say here is the polygon, because this is creating a polygon here, should not be closed. Great, so we've actually answered the question because it's only asked us for two things that are wrong. There's also another one that we could have noticed. So we haven't actually looked at the data yet. And if we look at this data and see how it's plotted, we'll be able to see that these are plotted correctly. But this first point here isn't. Because if we look up the table, the frequency is 6. However, on the y-axis here where the frequency is plotted, 6 would be here. So we've actually plotted 8 as a frequency, so that'd be incorrect. So you could replace one of these two saying the first point 15.6 has been plotted incorrectly. Cool, so to get the 2 marks, you only need to write 2 out of the 3 errors here. So the length of a pencil is 128mm, correct to the nearest millimetre. And we need to complete that error interval for the length of the pencil. So what we mean by the error interval is basically what are the possible values a pencil could be. Because we know 128mm is a rounded number. What is the highest possible length the pencil could be that it would have rounded to 128mm? And what's the lowest it could be that it could have rounded to 128mm? And then we'll know the error interval, so the range of values the actual length of the pencil could be. The lowest it could round up would be 127.5. And the reason for that is because anything less than that, so let's say 127.49999, it keeps on going. Anything lower than that, that would round to 127. Because we know if it's less than 0.5, we round it down. But we know as soon as it reaches 0.5, so 127.5 here, it rounds up. So this would round to 128. So that's perfect. This is our lowest possible value. Now when you think about the highest. Okay, so if I go the other end, I do 128.5. What would that round to? So that would round to 129. So we need to go one less. So if we do 128.49999, it keeps on going. That will round down to 128, which is spot on. That's exactly what we need. So this would be our number. This would be our upper limit. However, it's not very convenient to write 128.49999 and it keeps on going. So what we do instead, we can see here in the answer, here we've got a less than or equal to sign. So this is saying, okay, we're going to include this number, but this is just a less than sign. So up here, what I'm going to put is 128.5. because this symbol here is basically saying, okay, don't include this number, but any number less than that, just below it does work. So this symbol works perfectly. So it's saying, okay, not this number, but anything below it. We get 1 mark for correctly identifying the lower bound and 1 for the upper bound. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam stamps is 3:7. Tom buys some stamps from Adam, and then the ratio of the number of Tom stamps to the number of Adam stamps is now 3:5. How many stamps does Tom buy from Adam? And we need to show all of our working. So I'm going to start by filling in this table with some information from the question. So originally, the ratio of stamps between Tom and Adam is 3:7. And then after the transaction took place, it is 3:5. Now we know that all that has happened is that Tom has bought some stamps from Adam. So in each case, there's still the same amount of stamps. There's still 240 stamps each time. So what I now want to work out is what each of these numbers represent, how many stamps that actually is. So the way to do that is you add up the different parts of the ratio. So doing that for the original one first, we're going to have 3 plus 7, which equals 10. And then we're going to take our total, which is 240. And if we divide 10 by that, we get 24. So we know that each single part represents 24 stamps. So Tom here has got 3 parts of the ratio. So that's 24 times 3 stamps. Adam 7, so 24 times 7, and so on. Now I'm going to do the same thing for the new ratio. It's going to be 3 plus 5, which equals 8. So if we do 240 divided by 8, and there we get 30. So Tom's got 30 times 3 stamps, and Adam's got 30 times 5 stamps. And we're interested in how many stamps does Tom buy from Adam. So we're just going to look at Tom's column here and compare the original number of stamps to the new number of stamps. So doing the original first, we're going to do 3 times 24, which is 72 stamps. Then for the new one, that's 3 times 30 stamps, which is 90 stamps. So we know originally Tom had 72 stamps, and after he bought some from Adam, he had 90. To find out how many he bought, we can just do 90 minus 72, which is 18, and that is the final answer. So going through, we get 1 mark over this step here, 1 here, 1 mark for this step here, and the final mark for taking the difference and getting the correct answer of 18. Each person in a fitness club is going to get a free gift. Stan is going to order the gifts, and Stan takes a sample of 50 people in the fitness club and asks each person to tell him the gift they would like. The table shows information about his results. And we're also told that in total there are 700 people in the fitness club. So in part 1 we need to work out how many sports bags Stan should order. Okay, so essentially what Stan's done is he's taken a sample of people and surveyed them to see what they want. Then he's going to use the proportion of the amount of people that want each item and work out how many people that will roughly be for the 700 people. Now if we add all of these up, we should get 50, because we're told that Stan takes a sample of 50 people. So in our sample, we've got 50 people, and in total, we've got 700 people. So to get from 50 to 700, if we do 700 divided by 50, that's going to equal 14. Therefore, over here, we're multiplying by 14. To get from 50 people to 700, you multiply by 14. So we're going to use that number we've just worked out, and we're going to do the same for the sports bags. So within the sample, there were 17 people wanting sports bags. So if we do 17 multiplied by 14, our number to get us up to the total amount of people in the fitness club, we get 238. So therefore, it makes sense that Stan should order 238 sports bags. So within this, we get 1 mark for this working out here. So essentially, to work out, we need to multiply by 14, and a second mark for the correct answer of 238. Now, for the second part of this question, we need to write down any assumptions that we made and explain how that could have affected our answer. And there are lots of acceptable ways you could word this in your answer. But essentially, the idea is that the proportion of different people that want the different items within this 50, it needs to be representative of the 700. The same proportion want to have each item within the 700 people. So we've assumed that the sample is representative. And for something along those lines, you get 1 mark. So we're told that here there are 6 graphs. Okay, so this is sort of just something you need to learn. It's really good to just go through and learn the equations of different common graphs like this. So for part A, we're looking for the graph with equation y equals x cubed. and that will be f here. And for b is y equals 1 over x, and that'd be graph D here. And you get 1 mark for each of those. The nth term of a sequence is 2n squared minus 1, and the nth term of a different sequence is 40 minus n squared. And we need to show that there is only one number that is in both of these sequences. Okay, so we're just going to do that by generating some terms. So we've got 2n squared minus 1 and 40 minus n squared. So if I start when n is 1, so we're going to sub n in here. So we've got 2 multiplied by 1 squared minus 1. And feel free to use your calculator to do that. And you'll have 2 minus 1, so 1. Then we've got 40 minus n squared, so minus 1 squared, so 39. Okay, so now n equals 2. So we're going to have 2 multiplied by 2 squared. That's 2 multiplied by 4, so 8 minus 1 is 7. And same for here, we're going to do 40 minus 2 squared, which is 40 minus 4, which is 36. Now using the same pattern of subbing them in, we're just going to carry that on for a little bit. So I've gone up to n equals 7. I'm just going to stop there for a minute and see what we can see. So we're going to have a look if there's anything common between both of them. We can see that 31 is common. So that's great. We've shown that there's one number that's common in both the sequences. But is that the only one? We see this sequence here is going up, and it's continuing on going up. However, this one here is going down, and it's continuing on going down to the minus numbers. We see because this one's going up and this one's going down. They're going in different directions. So they're not going to cross again. This is the only point that they crossed. So therefore it follows that 31 is the only time that both these sequences cross. And if we've successfully generated all of these terms, we'll get all 3 marks for the question. Because it's clear from just writing out these sequences that they won't cross again except for at this point. So we need to work out 3.42 multiplied by 10 to the power minus 7 divided by 7.5 multiplied by 10 to the power minus 6, giving our answer in standard form. Well, we can see that these numbers are both in standard form already. So we've got a couple of options for this. We can either convert these numbers out of standard form, do the division, and then put them back into standard form. Or we could keep it all in standard form the whole time. And that's what I'm going to do for this example here. Now I sometimes find division easier to visualize as a fraction. So that's how I'm going to write it out. So we've got 3.42 multiplied by 10 to the power minus 7. And that's divided by, because writing it as a fraction like this is the same as saying this essentially. So we're going to have 7.5 multiplied by 10 to the power minus 6 on the denominator. So if we deal with these parts first, we're going to do 3.42 divided by 7.5. If you put that into your calculator, we get out 0.456. But we still haven't dealt with this part yet. So we're still multiplying that by 10 to the power minus 7 divided by 10 to the power minus 6. Now, if we think back to some indice laws, that's a good way to remember how to do this. If we have a to the power of x divided by a to the power of y, that equals a to the power of x minus y. So for this to work, it needs to have the same base in all of these. Well, that's great because here we've got the same base here. So we're going to have the same base here. And then for the powers, we're going to have minus 7. Now this is very important. It's minus brackets minus 6. It would be very easy to accidentally leave one of those minuses out, so remember that. So we're then going to have 0.456 multiplied by, if we minus a minus, that turns into addition. So we've got to the power of minus 7 plus 6, which equals 0.456 multiplied by 10. Minus 7 plus 6 is minus 1. So we got 0.456 multiplied by 10 to the power minus 1. However, this isn't quite in standard form. For this to be in standard form, this part of the number here needs to be greater than or equal to 1 and less than 10. Well, this is less than 1 at the minute, so what can we do? Well, we can shift everything over by 1 place, giving us 4.56. And that's great because that now meets our condition of being greater than or equal to 1 and less than 10. But how did we get from here to here? Well, we divided by 10, so we need to subtract 1 from the power, giving us minus 2. So that's our final answer in standard form, 4.56 multiplied by 10 to the power minus 2. And we get 1 mark for the working and 1 mark for the final answer here. The number of days, D, that it will take to build a house is given by D equals 720 divided by N, where N is the number of workers used each day. Ali's company will take 40 days to build the house, whereas Haley's company will take 30 days to build the house. Haley's company will have to use more workers each day than Ali's company, but we need to work out how many more. Okay, so we're first going to have a look at Ali's company. Now we're told with Ali's company that it's going to take 40 days to build the house. So using our little formula that we've got up here, that's going to be 40 equals 720 divided by M. Now what we've done, so we've got one unknown here of N, and we've created an equation. So we're going to solve this to find out what N is. If I multiply both sides by N, what we get here is effectively these N's cancel, leaving us with 40N is 720. If I now divide both sides by 40, these 40's cancel, giving us N equaling 720 divided by 40. Popping that into the calculator, we get that that's 18. So Ali's company uses 18 workers. So we've got to do the exact same thing for Haley's company. This time we're told it's going to take 30 days to build the house. So again, referring up to our formula, we're going to get 30 equals 720 divided by N. And again, let's rearrange to get N in the subject. So if I multiply both sides by N, we get the N's to cancel. So we're left with 30N is 720. We're then going to divide both sides by 30, and the 30's cancel on this side, giving us N equals, popping this side into the calculator, we get that as being 24. So Haley's company uses 24 workers. Now we're told that Haley's company will have to use more workers than Ali's company, but we need to work out how many more. So to do that, we just need to find out the difference. So it's going to be 24, and subtract from that 18, giving us 6. His final answer is that Haley is going to have to use 6 more workers. So we're going to get our first mark for doing this working here. So working out the number of workers that each company will use. Second mark for doing the difference. And the third mark for the correct answer of 6. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. And Janet says that the volume of the cube is equal to the volume of the cuboid. Is Janet correct? And we need to show how we got our answer. Okay, so firstly, what is the surface area? Well, we can think we've got all these sides. So there's 1, 2, 3, 4, 5, 6 sides. And on here, there's 1, 2, 3, 4, 5, 6 sides as well. If you think of them as 2D shapes, so here we've got loads of squares, here we've got some rectangles. If you work out the area of those shapes in 2D, of each of the sides and add that up, that's the surface area. That's different to the volume, which is the area that makes up this 3D shape. So we've been given some information for the cuboid. So let's look at the surface area of the cuboid. So we have a look at this side first. Have a look at this 2D shape. The area is going to be 6 multiplied by 8, which is 48. And because that's an area, centimetre squared. And let's have a look at this shape here. Because this length is 6, it means this length is also 6. So we've got 6 multiplied by 18 to get the area of that, giving us 108 centimetres squared. And now we're going to have a look at this top shape here. And that's going to be 8 multiplied by 18, giving us 144 centimetres squared. Okay, so we've got 3 areas, but remember I said because there are 6 sides, we need 6 areas to get the total surface area. Well, this shape here is the same as this shape here. This one here is the same as this one here. And the one on top is the same as the one on the bottom. Therefore, it's each of these twice. So what I'm going to do is add these up and multiply it by 2, and we get the total surface area. So we're going to have 48 plus 108 plus 144, which gives us 300 centimetres squared. And if we do 300 and multiply that by 2, so we're taking account for all of the 6 sides, that gives us 600 centimetres squared. So the surface area of the cuboid is 600 centimetres squared. Okay, we're told that the surface area of the cube is equal to the surface area of the cuboid. So we know this surface area must be 600 centimetres squared. So can we think of a way to work backwards and work out what the lengths of the sides are? Well, what's useful is that in a cube, we know that every length is identical. So therefore, the area of each of the individual faces or 2D shapes must be exactly the same. Therefore, using that fact, the area of one of the faces must equal, we're going to take the total surface area, we know that's 600, and divide that by 6, because there are 6 faces, giving us 100 centimeters squared. It's also the case that the length of each side in the cube must be the same. And again, we can use that fact. So since the area is 100 centimeters squared, each length must be 10 centimeters. And that's because 10 times 10 is 100. So if you imagine how we worked out the area previously, if this is 10 and this is 10, to get this whole area of this face here to be 100, it has to be 10 multiplied by 10. But because we now know that that's 10 here, 10 here, and 10 here, we can work out the volume of the cube. So the volume is height multiplied by width multiplied by depth. So that's going to be 10 multiplied by 10 multiplied by 10, which equals 1,000 centimeters squared. So that is the volume of the cube. Now we already have enough information to work out the volume of the cuboid, so we're going to do that. And again, height multiplied by width multiplied by depth, giving us 6 multiplied by 8 multiplied by 18, giving us 864 centimeters squared. So Janet's claim was that the volume of the cube and the cuboid were equal. However, it's clearly not, they're different. So therefore, in our concluding statement, we can say, no, Janet is not correct, since 1,000 doesn't equal 864. So we get our first mark here for finding the area of 3 at the sides and adding them up to get 300. And the second mark for multiplying that by 2 to get the total surface area. We get another mark for then using that to work out that one of the lengths of the cube is 10 centimeters. We get another mark here for working out both the volumes. And then a final mark for the concluding statement, basically saying, no, Janet's incorrect. Here are 2 column vectors, A and B. On the grid below, draw a label with the vector A minus 2B. Okay, so we've already got what A is. A is 5, 2. Let's see what 2B is. Now we've got a vector here, B, multiplied by a scalar, 2. So what that means is if we got 2 multiplied by, I'm going to write out B in full in its column vector form. We're going to multiply 2 by the 3 and 2 by the minus 1, giving us 2 times 3, 2 times minus 1, giving us 6 minus 2. Therefore, we know that A minus 2B equals A, which is 5, 2, minus 2B, which is 6 minus 2. And that equals, and we basically subtract matching elements, so the top and the top one and the bottom and the bottom one. So we've got our final vector being 5 minus 6 and 2 minus minus 2, giving us minus 1. And if we minus a minus, that turns into plus. So 2 plus 2, which is 4. And one thing I've noticed is I should have underlined these to show that they're vectors. So I've gone and done that now. Great, so now we need to show this vector on the grid below. And what this vector represents is the top one is our left right, and our bottom one is our up down. So minus 1 is saying we need to go left by 1, and this 4 here is saying we need to go up by 4. So let's just say I start here. We're going to go left by 1 and up by 1, 2, 3, 4 till here. So if I join those up to create our vector and do an arrow so we see the direction we're going in and label that A minus 2B. And we get our first mark for this part working here, second one for getting the vector minus 1, 4, and the third mark for drawing the vector on the grid.